Alright, so I'm going to show you how to estimate square roots and cube roots. So we're going to just start with square root of 8, just for an example. So I don't know what the square root of 8 is off the top of my head, but I can use square roots that I know to estimate what this number is. So the closest perfect squares to the square root of 8 are going to be the square root of 4, I know that one, and I know the square root of 9. And I know this is going to be in between those. So the square root of 4, I know is 2. Square root of 9, I know is 3. So that tells me that the square root of 8 is somewhere between 2 and 3. Well, okay, which one's it going to be closer to, though? Let's think about that. So 8 is 1 away from 9, and it's 4 away from 4. So what that tells me is that the square root of 8, it's going to be a lot closer to the square root of 9. So it's going to be somewhere over here, it's going to be closer to 3. So now I just start estimating and kind of guessing and checking. So what's a decimal that's between 2 and 3, but closer to 3? Let me just try 2.7. So to test this out, I'm going to square this and see if I get close to 8. So I'm going to put this in the calculator. So 2.7 squared gives me 7.29. Let me jot that down. 7.29. So I'm a little too small. I'm not quite at 8 yet. So I'm going to adjust my estimate and go up to 2.8. And let's see what I get there. So 2.8 squared is 7.84. All right, so I'm still too small. So let me keep just adjusting my estimate till I get kind of close to 8. 2.9 squared gives me 8.41. So now I've gone over 8. So what that tells me is that the square root of 8 is somewhere between 2.8 and 2.9. So it's going to be somewhere in here. To get my final estimate just to one decimal place, though, how do we decide which one to go with? Well, 7.84 is 0.16 away from 8. And 8.41 is going to be 0.59 away from 8. Well, this one's closer, so that's going to be my estimate. So the square root of 8 is approximately 2.8. And just so we can test that, square root of 8, I hit equals, it's 2.8 if we round it to one decimal. All right, what about if we're talking about cube roots now? We're not talking about square roots. Let's try something else out. Cube roots, we're going to do the same exact process. The only thing that's going to change is instead of finding perfect squares, we're going to find perfect cubes. So let's, for an example, just do the cube root of 10. I don't know what that is off the top of my head, but I can find the two closest perfect cubes. So I know the cube root of 8, and I know the cube root of 27. This is in between those. So the cube root of 8 is 2. The cube root of 27 is 3. So like we said, the same exact process that we did before. Which one's it closer to? Well, 10's only 2 away from 8, and it's 17 away from 27. So it's going to be a lot closer to 2 than it is to 3. So here's where we just start testing out our estimates. So let me try, what's a number between 2 and 3 that's closer to 2? Let me try 2.2. Now when I'm testing this, instead of squaring it, I need to cube it now because I'm talking about cube roots. So if I'm going to test this in my calculator, what I'm going to do is do 2.2, this caret, and 3. I get 10.648. 10.648. Well, my estimate's a little too big here, so let me change it. Let me make it smaller and do 2.1 cubed. So 2.1 cubed is 9.261. All right, so now I've kind of found it's going to be either 2.1 or 2.2. Like we said, same process as before. Which one is it closer to? It's going to be one of these. So 10.648 is 0.648 away from 10. And 9.261 is 0.739 away from 10. So this is the closer one. It's not as far away, so I'm going to go with 2.2. Now, to test this out, let me just see what the cube root of 10 is. And the way to do that in your calculator is you put 3, and then you're going to go to second, this button right here, 10, and I get 2.15. Well, if I round that to just one decimal place, I get 2.2. So that's my estimate.